PR tour. I'm Helen Smith and I'll be running the webinar behind the scenes today. But before I pass you over to my colleague Andrew McCall, who will introduce the session, could I ask that as you come in, then you put yourself on mute and keep your cameras off. We'll have plenty of time for Q&A at the end, so at that point you can either come off camera, put your hand up and we'll come to you in time, or pop your questions into the chat function. The webinar will be available on our website at a later date if you want to have a recap on anything. But for now, I'll pass you across to Andrea.
Thank you, Helen. Hello and welcome everyone. I'm Andrea McCall. I work in the Life Sciences and Blue Economy team at Highlands and Islands Enterprise here in Inverness. And I'm delighted to welcome you to the webinar today. I'm just going to, before we get started and I introduce our speakers today, I just want to give a quick plug to an event that we're hosting in September. So Christine, if you could show us the next slide, please. I'm working currently with colleagues at Scotland's Royal College on delivering this conference, the A3 Scotland Conference. And it's a conference for innovation in animal health, agritech and aquaculture. So it is related to controlled environment agriculture as well. So I just wanted to share information about the conference with you today. And please pass this on to anyone who may be interested in attending. There is the two-day conference on the 18th and 19th of September will take place at the King's Mills Hotel in Inverness, and you can register online. You can see the link there. It's www.a3scotland.com/registration. And Kirsten, if you go to the next slide, we'll see that there's also a set of additional events apart from the main conference. And it's those are happening on Monday the 16th and Tuesday the 17th of September, and they're all free to attend. So again, please have a look on the website. So there's a specific link at the bottom there for the fringe events. And they are a mix of webinars, hybrid and face-to-face events at Inverness campus. And there's different stuff in there around agricultural robots, robotics, aquaculture technology, also 2 sessions on lean thinking in manufacturing and using hidden data in manufacturing. So quite a lot in there. So I would urge you to have a look at the website and see if either you or anyone else you know could be interested in attending. So before I go and introduce our speakers for today, I'll just hand over quickly to my colleague Alistair Brown, who's in our innovation team, because he wanted to share a couple of things with you as well.
Thank you for that, Andrea. And yes, so as Andrea said, my name is Alistair Brown and I work for Highlands and Islands Enterprise within the innovation team. So I'm just going to very briefly go over this single slide here outlining the innovation support that Highlands and Islands Enterprise can offer. There's 3 sort of main elements to this support. So just on the slide, working from the left, we can provide advice and support to businesses and groups that are looking to explore opportunities around innovation and research and development. So we can provide specialist advice, we can do a review or innovation review looking at opportunities that businesses may have to explore innovation. IP support, so IP intellectual properties. We also provide support and advice to help businesses make sure that they cover any intellectual property as they develop their products and services. The middle element of the slide focuses on knowledge exchange. So knowledge exchange is a variety of elements, including learning journeys. So in our program, we have the ability to organise learning journeys, which could be to industry centres, research centres. It could be collaborative journeys to specific areas or specific groups of people who want to meet up and learn more about innovation and research and development. Events like we're having today, we can organise webinars and face-to-face events. Webinars obviously have a wider reach, but events can be also organised in areas where there's specific interest in research and development and around the HIE region. The New Product Development Accelerator is a programme that we offer, which is a mixture of online and face-to-face, and this is allowing businesses that want to develop new products and services. There's specialist tailored support to cover that. Our next cohort for the NPD programme is likely to be around the start of 2025. But if you follow HIE on social media, LinkedIn, Facebook, etc., then you'll get updates of when this support is available. As well as the NPD programme, we also are doing some smaller events, fringe events, and these are going to be held in Shetland, Fort William, Portree, and Harris in the Western Isles. We're also hoping to organise events in Orkney, Caithness and Sutherland, Moray, and around Inverness area. So these sort of accelerator events will be tailored to businesses and groups that are maybe looking at new products and processes. So once again, if you follow us on social media, you'll find out more about these events in the future. Just finally from me, a quick overview of funding. Within HIE's innovation programme, we can offer a Research Development Innovation RD&I grant. So that grant generally is available to businesses that are looking to develop new products and processes. We can help in people testing prototypes and processes, and the funding is generally between £25,000 to £100,000, although we generally would encourage anyone who's thinking about projects to come and speak to us, and we can see what potential support might be available. If it's not through ourselves, then there is other external funding application support that we can offer. There's a variety of funding available through national bodies such as Innovate UK, Scottish Government, as well as regional opportunities for funding. So I'm going to stop there, and I believe our contact details are on the slide. So I would encourage anyone that wants to discuss innovation, research, development ideas just to get in touch. And thank you very much.
Sorry, I was on mute there. Thanks, Alistair. Yeah, we're moving swiftly on after this lengthy introduction, and I'm delighted to welcome Douglas Elder from Intelligent Growth Solutions, who's joining us today. And Douglas is actually going to speak at the A3 Scotland conference in September in Inverness, but we're delighted to bring you this special feature today where you can all join in a tour around the vertical farm. So I'll let Douglas introduce himself, but he is the head of Vertical Farming Solutions, and he joined a company in 2015 to actually, I believe, project manage the setup of the first facility at Invergowrie. So we're very much looking forward to seeing it in a minute after you've introduced us to what IGS do. Thank you, Doug. Over to you.
Thanks, Andrea, and thanks everyone for joining today. Apologies if it gets a bit wobbly or anything at any point. I'm sure Andrea will shout at me if it starts going a bit blurry or anything, but as this will be a live virtual tour, there will always be some hiccups along the way. So please bear with us as we go through it, but we think it will really bring a much more sort of interactive experience of being able to see the farm in real time and show you what we do here at IGS. So again, welcome to Intelligent Growth Solutions. We have effectively been operating on this site since about 2018. We started commissioning, as Andrea pointed out. I was brought in originally to project manage this facility. So ultimately, I have a background actually as a geologist, so I'm still questioning some days as to how I've ended up here, but I guess that's the no wrong path option. But essentially, it was coming in from the energy industry, which is the elephant in the room of vertical farming. Is how do you deal with that part of this where you're taking what is normal naturally produced sunlight and using electronics and LED lighting to fundamentally grow the plant. So there was a really exciting opportunity when I was introduced to IGS, and it was effectively a 3-man in a shed operation when I joined. But it's really been an exciting journey throughout that process of taking it from that into what we now are presenting to the world today and starting to deploy globally at scale. So next slide, please, George. So when I joined IGS, it was, as I say, a very small team of people. Ultimately, what is really critical for us and what was a really important part of our journey was that we were founded by a farmer. So Sir Henry Aykroyd had been farming for decades around Scotland and in the US as well. But ultimately, he was navigating the challenges of of modern agriculture, where the weather is never doing what you want it to do. The products and the inconsistencies in the product from a result of the weather events and things like that are always impacting your ability to predict what's going to happen next year. And also the interactions with retailers were really driving him to look at much more sort of controlled and processed ways of growing. And ultimately, he started to look at this concept of vertical farming that we'll touch on in a minute. But essentially, out of that sort of growing background, we've effectively spent now £12 million in R&D developing the system that we are taking globally. And that's attracted £81 million of international investment from some of the top agri-tech businesses in the world. So as a small Scottish company, it's been really exciting to see us grow and get that international recognition of the technologies that have been developed here in Scotland, working with science institutes like the James Hutton Institute as being a really critical part of our journey, and those sort of local interactions of being able to take that to the next level, working with the likes of Scottish Enterprise and investment from the Scottish Investment Bank and things as well. So what is IGS? We are an infrastructure provider. And what does that mean is also a big and broad topic. But fundamentally, what is vertical farming? I'm sure a few people are now familiar with it. Again, back in 2015, when I joined, I had literally no idea. Ultimately, vertical farming is the process of any kind of stacked layers of growth. So it's not greenhouses where we have the horizontal beds, it's not fields, it is where you start to do and stack these things up and reorientate the crop. And it comes in a lot of different formats. So anyone that's navigating the internet and looking for different things will see lots and lots of different shapes and sizes. Some use natural lighting, some use LED lighting. And ultimately, there is no right answer effectively with this. So we've spent a lot of time and effort in what our version of vertical farming is. And as part of that, what we realized was that there was a lot of people trying to develop the product as in the technology as well as be growers. And so it was quite an early decision in our history that we said, look, we need to focus on the technology to be able to deliver the best product out there. And that was a really important part of our journey because there was an absolute niche there that nobody else was kind of looking at. And that meant that the type of investment that we needed was much less. If you look at some of the US companies, they've had to attract over $1 billion investment, and it's still not been enough because they're trying to obviously grow at scale and develop a technological product. So us being that technology provider and considering ourselves this sort of infrastructure for vertical farming, this technology for vertical farming has been a really important part of that decision. So there we go. So why farm vertically? So there's a number of benefits that we can see. There's the obvious choice of when we're taking what is now total controlled environment agriculture, where we are eliminating all of the natural variables that can influence how those plants grow. We can now make sure that things like pests, disease, molds, human interactions, all of these things can now be controlled. So you end up with a much cleaner product, which means that you don't have to use those chemical interventions. As a result of that, and being able to actually grow closer to the market, you also reduce the shelf life, improve nutrition, as well as being able to use less water, less nutrient mix, and these sorts of things. And a big part of it is that actually, if you do the technology right, you can work directly with renewables. And actually, that changes that localization piece where we can start looking at remote locations with an energy abundance and actually have an exportable product rather than trying to move electrons. We can move kilos of salad or whatever other products that they're looking to do. So it really creates some interesting opportunities beyond the sort of more traditional growing. But a big one is you can just grow year round the products you need when you need them in a way that is massively reducing wastage, because you're effectively now able to grow to order, not to season. So you don't get that seasonal abundance that overflows the shelves and can put the food, what food needs to be where or whatever product it is. So for IGS, it was about setting up this commercially viable vertical farming solution. And again, there was two key challenges with vertical farming in its early infancy was energy and labor. So how do we reduce the amount of power we need? And how do we reduce the labor load that is normally needed in traditional agriculture? One of the big ones for the labor side is automation. Super simple, and we'll see some of that as we move around today. just bring in the automation element, and we can replace the need for people who have to inspect the crops, who have to be able to do a lot of this sort of chemical interaction, and a huge amount of labor is required just for that monitoring of the crop in these larger span facilities. Here we can start to automate all of those processes from the movement to the actual monitoring of the crop. And also from the power side, we can start looking at how we reduce the amount of power overall and work, as I mentioned earlier, closer to how do we use that renewable energy that could be in abundance in a location, and actually start using spare capacity from renewable assets as well. So really we wanted to set out and make the technology achieve these main goals. And it was a long journey in R&D. We spent a lot of time making sure we could do that. And one of the big considerations is that plant science is inherently slow. So we wanted the ability to avoid obsolescence through the hardware actually doing way more than it needs to do today, so that we have the capability for it to do it in the future once the plant science can catch up with those processes. And that's really what we're going to be seeing today, is that combination of all of these different functions: the engineering, the agronomy, the crop science, the data science is in action in this facility behind me. And ultimately, that's what IGS offers, is this long-term solution where we're able to continuously optimize and improve the products that we have and improve the product range that we can offer, so that we're able to start sending that to the growers that have bought the system already and continue to adapt to the new challenges that the modern world will throw at agriculture in general. Some of the specific benefits of IGS are that, you know, and some of vertical farming are that we are able to increase the number of harvests significantly just because you don't have that seasonality element. So even compared to a glass house, it could be a high-tech glass house, fully lit, heated, we're still able to outperform that just because we can add the right energy where we need it in the right way to really promote the growth of those plants. We've done that in a way that for IGS is a third less compared to other vertical farms. And that's really through what we call photon optimization. And you'll see how we do that as we go around the farm. And the next big part is just less water. And less water means less nutrient as well. So the water that we put into our facility, majority of that is consumed by the plants. We have very little waste that comes out of that. And even that wastewater can be used by others in other agricultural practices nearby. So that is not really a waste product, and that offsets what would be used in some of the field grown around this area for us and for our own growers, people using our system as well. Okay, so just so you get, because it might be a bit abstract just from the virtual tour, but just to show you what we're going to see, this is kind of how we lay these things out. So you'll see a plan view there on the right of the growth tower. And when we talk about a growth tower, it's a combination of this racking system with two sets of static racks and a central lift mechanism. So this will be what you see there. What you can see on the left here is a sort of 3D breakdown of that. And ultimately, what I won't be able to show you the upper level today, but in the lower level, you'll see the access to the tower. But above our heads, there will be the irrigation and nutrition systems and the ventilation system that's also doing the dehumidification sits above that. So it's really about trying to cram as much of that technology on as small a footprint as possible. And you'll see here from the 12-meter facility, we're able to get 520 square meters of growth area onto that 41 square meter footprint. And that, if you imagine, that's already 3 times more productive than a glass house. That now is at 1,500 square meters of growing area, effectively equivalent. And in some products, we're seeing it's far more than that. So that's some of the stuff we'll cover as we go around now, but hopefully that gives you a sort of less abstract view of the world as we go through. Perfect. So over to the tour part, and that means you don't have to look at my face anymore. So please bear with me, we just arranged that piece. And I think it should be spotlighted any second now for that as well. Georgia, you got the spotlight? Perfect. Cool. So what we're looking at here, as mentioned, we're based here in Invergowrie, just outside Dundee, on the campus of the James Hutton Institute. So the James Hutton has been a fantastic partner for us. They are by default our landlords, but we've had a number of collaborations that have helped us really develop this technology. So for those that don't know, the James Hutton Institute is a world-renowned crop research centre. And the investment they've been putting into this place really helps lift us as well. So they've got all sorts of new services with the Advanced Plant Growth Centre and International Barley Hub that will complement what we're doing, and hopefully our technology can help them develop further with those assets as well. But fundamentally, they've helped us really understand the deep science of what we're doing in the plants in our early days, and given us the capability to build the technology to what can accommodate that. What we're looking at the moment is a six tower facility. So these are 9-meter towers. As I say, we can do a 6, 9, and 12-meter tower facility. the 12 definitely gives more bang for its buck, as every square meter, just the cost per square meter comes down as it's shared infrastructure over a larger growth area. But the 9 meters is what we have here. Effectively, it's packaged in a cold store type box with the steel exoskeleton there. And what the cold store is doing is effectively the opposite. It's keeping our heat inside the building that we want to be there, and allowing us to remove any of that radiant heat and any of that sunlight that would be penetrating, and on colder times of year, any of that cooler temperature that would affect that growth environment. So we're able to maintain a very precise temperature within the growth area and be able to really control that process, as opposed to what you would experience in a glass house or a polytunnel throughout the summer. Even during today, the temperature has been all over the shop. So it's effectively, we do the technology that sits inside the box. Our customers build the box for us to put it in, but we have very detailed engineering packs that allow us to be able to do that. That building also has to be able to deal with wind loading and snow loading and things like that as a new build, but it is a single envelope. So it can actually save money by not having to build an existing structure, a new structure to be able to house the towers. It is the towers themselves can be the same superstructure, and that could be bolted onto the side of a new building as well, or an existing building, or we can reduce some of the steelwork and actually build that into an existing building, which we've also done as a retrofit option where there is a warehouse type building available, as long as it's got the clear height. The building itself, you'll see some pipe work coming in there. That's our chilled water network. So essentially what we have is a centralized chiller plant that's just pumping cold water around that to control the temperature in each of the towers. And each of the towers is individually separated here. So when you look back at that floor plan, each one is its own growth chamber. And in there we can control temperature, humidity, and CO2. And effectively, we have 3 towers on this side, central handling area, an upper plant room, and another 3 towers over on the other side. We're actually only operating 5 towers in this facility. We will at some point put the 6th one in, but that's being used as a lab space at the moment, as most of our operations are carried out inside of polytunnels like the ones we'll see here. We'll head in, and as I mentioned, on the automation side, we actually have created, so we focused on the technology that actually the world is pretty good at feeding machines already. So we didn't want to reinvent the wheel where we didn't have to. So you'll see this looks pretty practical, very horticultural in here. It's still a horticultural option at the end of the day. So we didn't want to reinvent the wheel. We don't want to tell growers how to do things differently. We want to make sure that we're complementing what they already do. And this is where we start looking at things like hybridization facility and put them into environments like I'm standing in, or into the open field as an option as well. So the seeding machine you'll see here effectively comes from a third party, and customers can buy any size, shape, or flavor of that they want. And it could actually be somebody as simple as somebody manually seeding, should they want to choose that. So they can choose the level of automation that suits their requirements, but effectively allows them to scale that. So we effectively had to standardize what we offer our customers from how we interface with that kind of equipment, and use what is already used in horticulture. So you'll see here we have these black trays. They're not the most exciting things to look at, but these are where we'll put our seeds and through the seeding machine, through a substrate. Those seeds are then placed on top, and then we can germinate those inside a chamber here. But effectively, that process already exists in horticulture. Really got that refined through what has been done in the past, but these trays are all the same. Sorry about that. Yeah, did warn out we may have a few glitches along the way, but effectively these trays allow us to select the right format for whatever crops that we're going to be putting through the system. And that diversity of crop has actually allowed us to do everything from microgreens, high-end microgreens, very high nutrition, powerful flavor, right through to things like mini tubers for the seed potato industry that have been run through the trials that we do in quite large pots. And that's through the hydroponic system that we use. The substrates we use can vary. One of the big advantages, again, of the type of hydroponics we use here is that we can use quite a broad range of different substrates. Most of our trials are carried out in cocoa coir, so a byproduct of the coconut industry. But effectively, customers can use anything that's coming through in terms of the new products. We always try and stay away from peat for obvious reasons. But essentially, it gives the customers the ability to be very flexible in what crop they grow and how they grow it. We'll now go into the growth tower, so we'll just walk around. And you'll see as we go around and say that the chambers here, you can imagine how tall the 12-meter facility is, quite imposing. So we currently have those operating in the United States. But effectively, we're just going to go into the airlock here. You'll see one of the trolleys for moving liners around the facility. And we're in the process of moving a few operations about at the moment, so I do apologize. So what we have here is effectively the entrance to the growth towers. So this is an airlock system, and its primary function is for environmental control more than for biosecurity. So we have quite low biosecurity measures in place here. A customer can choose how high of that sort of high care facility element they need to put in, but it has to be appropriate to what they're trying to do. So there's no point in just putting in high levels of biosecurity, because it costs a lot of money to do that if you're doing a product that doesn't necessarily justify it. So here, we're a very open facility, but we do use this from an environmental control, as we're only replacing the air that we lose through the airlock on that interaction, as opposed to all of the air through the tower all the time. And that'll become more important as we go through as to why. So you see as we come in, all of these doors are on an interlock as well, so I can't open the next door until this one is closed, sealed, and allowed the building to repressurize. We have a time period here where we have to wait. Because any of our staff would be coming in here, they would be then sanitizing and things like that. And effectively, it allows us to come into the growth area, essentially. So, as I mentioned, outside, we have these 5 chambers, as we call them, the towers. And these towers are essentially allowing us to be able to do different trials of different temperature, humidity, and CO2 level at each of the spaces. So we can grow very different crops in between the spaces. But what we're then doing at the tray level, as you'll see in the tower, is effectively allowing us to create microclimates, primarily driven by the lighting within that space. So we'll just go into this tower. So you'll see here, as I mentioned, from the plan, you have these 2 sets of pallet racking, essentially. And this is just off-the-shelf pallet racking. We've modified it somewhat to allow these very large, what we call GTLs, growth trays with lights, that are then static within the system. And then right at the top there, I'll get the guys just to bring that down for us so it's a bit closer, is the lift, so we can have a slightly closer look at that. But essentially, what we wanted to do with this is be able to use the lift to move the trays out. So the lift comes down this shaft, pulls the tray into the middle from either side, and then brings it down to the opening, where we have a special slot here, where we can then slide that onto it and move that and use that trolley to lift it out and take it out here. So the idea is people are not working within the tower space. And that's a really important element from a biosecurity perspective, that we can reduce the amount of human interaction. But what we've also done is build all the electronics into the GTLs. So all the lighting and all the controls of that GTL are actually built into it. So when we remove that, we can take all of that equipment out of here, and we can clean it, we can maintain it appropriately without having to climb the tower and go and do all of that stuff up there. So if you just bear with me, I'll just get the lift brought down a little bit so we can have a closer look. One sec. So just while we're getting that lift brought down, we have the lighting is obviously one of the critical elements in here. And as we were talking about that sort of process of photon optimization, ultimately, so ultimately, the lighting is effectively controlling how that plant grows. It is the primary driver of how a plant interacts with its environment. So in a polytunnel or in the field, effectively it is the sun that is doing that, and it's given all the colors of the rainbow in order to do that. But actually there's this process of photosynthetically active radiation where the plant is interacting specifically with a very sort of narrow band of that spectrum that the plant is actually using for photosynthesis. And then it goes beyond that. It is actually using some of it for how it grows, its morphology, and how it looks in terms of its taste. So these secondary metabolites are really what drive that process for the plant. We're using a combination of red, blue, green, and far red lighting within here. And that's really what we're doing, is taking the bits of the spectrum that give the plant the energy and the instruction it needs to be able to interact with that environment appropriately. Unfortunately for us, every variety of every plant at every growth stage wants a slightly different combination of those colors at what intensities and when. So it creates a really big science challenge in terms of how do you build those recipes up. There's some fundamentals that you can get right and you start growing everything. But what we really want to do is optimize that. And we wanted to be able to do that in the most efficient way possible. So it's really about removing that energy. So compared to a white light here, as I mentioned, we also, this is the broad spectrum. We have these narrow bands that are really allowing us to be able to do that. And basically what we can then do is start controlling that throughout the tower. The challenge being, when you start doing that, you create absolute havoc with your electrical system. So we had to kind of go back to the drawing board. If you want to control lots and lots of LEDs in a small space, you have to do that with a very controlled process of being able to switch those lights on individually without blowing your power system up effectively. As the consequence, your LEDs will just explode. So we had to kind of go back to the drawing board a little bit. And this is where our CTO, Dave Scott, really came into it. He brought the automation originally into the company from a company called Tornado Storage Solutions. We evolved and we ruggedized that automation piece, but essentially then started going back to the drawing board about how LEDs are fundamentally powered. And it really comes down to this infrastructure here, where we essentially are taking a high voltage mains power, and we're dropping that voltage and using actually a three-phase power system, take that to the LEDs directly. And that was unique. This was one of our most important patents in how we learned to control the LEDs, was it gave us a huge number of advantages of how we work with energy infrastructure. And actually we can start doing that in a way that is a positive. It also brings us a number of safety benefits, because now I'm dealing in a system rather than high voltage mains power, everything in here is extra low voltage, which means even if I'm standing in a puddle and I start playing with the power system, I'm still going to be alive, which is obviously good for your staff retention as well. Being able to have those interactions between the plants really was the fundamental point. The problem for us in the early days was nobody had made a light that could do that. So we had to invent the technology and then actually start building our own LED lamps to be able to include that in the technology. But that gave us an advantage, because ultimately it meant that we could start interacting much better than anybody else had been trying to do previously, where, if you want lights, you go to one of the big lighting manufacturers, you buy those. You buy racking from somebody else, you buy automation from someone else, you buy your HVAC system, you try and cram it all together. None of it's really designed to work together. So this gave us the opportunity, because we had to get to that really back to basics of, we're literally putting LEDs onto strips to build this thing. We could now look at every single interaction amongst that operating system to be able to start getting down to how it needs to work together to get every little efficiency we could out of the system. So that interaction with the lighting was kind of the first part, where we bring that to the plants, we design that and develop that, and we build the crop research centre so that we continuously optimize that piece. And to be able to do that, you'll see the lift just coming down in the background there, the umbilical cord, so just get that moved into a position where we'll actually be able to see it. But ultimately, we can then use that lighting. It is generating heat. It's not 100% efficient. So we'd love it to be, because it makes life a lot easier, but effectively the LEDs are generating heat in here, and that allows us to be able to then actually use that heat to preheat the air that comes into the facility. Because obviously to dehumidify that, we have to take that energy, that water out of that air using cooler temperatures to get it to condensate. And then we can bring that air and reheat it and cool the electronics actively. And that saves us about 28% efficiency in terms of our HVAC energy consumption compared to other systems. So this is really where you start building up all these different little efficiencies along the way that allow us to continuously optimize and develop that, but also have all of the interactions considered. So you'll see here the lift. It's a bit easier to explain the automation piece now. It's not at the top of the chamber. So you'll see it is quite a big facility we have here. People don't want to climb up there very regularly for obvious reasons. So that's where the lift comes into and is doing the bulk of that work. So once we've got the ventilation and the crops have the light, the ventilation, we're able to control that temperature, and we're able to do that uniformly across the tower. We're actually then able to dynamically control that so that the lighting load is then allowing us to control the temperature in interaction with the HVAC system through some of the technology that sits behind that as part of it. That air is all positively pressured, so it allows us to have more biosecurity in terms of that these trays are not interacting with each other even at the air level. All of that air, we have about 50 to 60 changes per hour on each one of these trays that we're moving a huge volume of air across that crop. And that's then extracted at different points within the tower where we're able to then UV sterilize that air before we put it back in. So it helps make sure that that air is clean. It helps make sure that we're not spreading anything that could be present within the facility through just general accidents and people not following procedure. But that stuff doesn't become a problem, essentially. So it allows us then to positively pressure that air out into the central handling area, where we can then positively pressure that into the airlock. And we're only bringing HEPA filtered air into the facility to replace, as I mentioned, what's coming through that airlock. And because it's such a small volume of air, we're not having to condition that air in any way, because even in the more sort of extreme climates of the desert or the far north of the Americas or anything like that, we don't have to do much to that air to be able to use it. So it really reduces the operational cost on that side as well. The irrigation is obviously the next thing you have to do for plants. We have to make sure they're watered. So what we decided to do was actually build that into the lift. So this is a bit of an older lift. They're much slicker than this now, but essentially you'll see that we have these brass nozzles here, and those essentially line up with these white pipes and then jet the water onto the tray. And what we're using is a process of ebb and flow hydroponics, essentially. So that's allowing us to be able to essentially schedule and how much water and how frequently we do for each crop at each part of the growth cycle as well. So we can basically give precision nutrition and fertigation to these plants, make sure they've got the best feed cycle for that as well. So you'll see here we have a lot of mixed use plants on these trays. That is not what we would do in an optimized facility. This is just more for demonstration for basic R&D while we get fundamentals right. We're able to test a lot of different plants in a small space, but actually in a full tower facility, what we're seeing is that in a larger facility, all of these trays would be one specific crop. As well, we won't be looking at mixed types of products here where we have a red leaf and a green leaf, because we can't optimize for all of the characteristics that both of those plants need. We want to make sure we're giving the best of the green and the best of the red, and whatever other variety might be in there, we're able to start splitting that down and making sure that we optimize all of the growth parameters we put into that. And from that, we're able to start controlling, as I mentioned before, the leaf size, the taste of that leaf, the nutrient contents of that leaf, and actually starting to factor in the bits of the product that we want to be optimized. So it may be that I'm using it for an extract. So I want to increase a certain flavor profile so that I can extract that component of the plant. Or it may be that I want to tone something down because it makes it more accessible. So people are maybe, things like basil can sometimes have an aniseedy flavor. We can actually remove that aniseedy flavor, make sure we maximize the other flavor profiles. And that means you also have to use less of it. You'll also see we have things like flowering products here. There's two reasons that we're testing these. One is the high-end edible flower market, which is, it's obviously quite a niche market, but it is a very profitable one for growers. What we're actually doing is then using the lighting to trigger that flowering response and keep that flowering response going. We're actually seeing that we'll get about, it's about 200 flowers per it's about 400 flowers per 100 plants every 4 days that we're able to extract that. So you'll see there's a very high number of these violas flowering here, and they'll just keep continuously doing that for at least 10 cycles for that process. So we're getting a lot of flowers off that, but we may actually just want to trigger that flowering response from a scientific perspective to be able, or for a developmental process in other types of plants. This is probably the oddest plant we grow here. This is something called the toothache or buzzflower. Essentially, it's the weirdest thing you will ever eat if you're ever given the opportunity, and be warned. It's also known as the electric daisy for very good reason. So it looks like a daisy, but it doesn't have the petals there. Essentially, that will make your mouth feel like you're licking a 9-volt battery. So it's really got that sort of Szechuan pepper type effect as well. So a really unusual one, but it is something that we can actually use and test. And actually the root has quite a lot of anesthetic properties, hence the toothache part of the name of that. So these sort of products are allowing us to test a number of different conditions, a number of different interactions between the plants, and allow us to then really focus on what we want to then take that R&D to a wider perspective. Once we start narrowing that down, we can then really start scaling those trials up in here and start using the technology and the scale of the technology we have to generate what we call that growth recipe, which is primarily the lighting process, also the nutrient mix that we've used, as well as that scheduling of the irrigation and the format that we do to get the best yield or the best type of product that we want out of there from a quality perspective. One of the sort of earlier requests that we had that's kind of become one of the most interesting ones is actually in relation to tree products. So I quite openly was very cynical about this, probably a little too cynical that it delayed things, but trees didn't seem like a good fit in terms of the growth cycles. A normal tree seedling can take about 18 months to 2 years to get to maturity. That doesn't fit with us having to burn electricity to be able to do that. So fundamentally, it looked like it was going to be a real challenge. But what we had found was actually through the trials, once we were finally convinced, was that we can grow things very quickly. So you'll see here, we have these coastal redwoods. These were planted, seeded on the 17th of July. So you'll see the development that we're seeing here already is very rapid. And what we've found is actually for most of the tree species we've tested, we're taking that 18 months down to 3 months. So all of a sudden, the economics is turned on its head and the commercial viability of that is turned on its head through the acceleration of being able to generate that product much quicker. And that really opens up how we operate. So we either need things in here to stay alive for a long time continuously. So fruiting crops need to be able to be continuously fruited to be sort of viable, or the things need to grow much faster. And that's what we're seeing with the tree products, is that this changes how that market works. It is quite disruptive because now I've got a much easier predictable business model in terms of what trees need to be planted when. I can adjust what trees I'm seeding to be able to adapt to the current weather situation for that season. And I can also start planting out what's in demand much, much sooner because I can respond to market conditions as opposed to having to predict 2 years in advance what those market conditions are going to look like. So it's been a really exciting one to test. And obviously, it's a big diversification from what people normally associate with this kind of technology is edible flowers, microgreens, all that really high-end, fast-growing stuff. Actually starts making us look much more at these sort of almost commodity type products that we can start exploring. So having this facility for us to do our R&D in really does open up, and it's actually allowed us to open the doors to the market to say, well, what do you think this technology is useful for? Rather than us determining and saying, we want you to grow this, come to us, open the doors, work with the people like the Hutton, work with the traditional growers and say, can we solve your problem for you? And what we're finding is a resounding yes to a lot of situations where this technology is applicable, much more beyond what people thought it should be used for, but looking much more at that sort of interaction with traditional horticulture and agriculture. So that's been a really exciting part of that journey for us as well, in terms of what we thought this should do versus what we're actually doing has really developed over time and has raised a number of real opportunities and identified a lot of problems that personally I found quite shocking in some cases in terms of how the food system works, how those interactions between growers and propagators and nurseries and things like that, and how tied together some of these things are, but how fallible they all are as well. So it's really helping us build that technology to suit the needs of the market and make sure that it's got a use outside of that as well. So that's kind of a very obviously high level, quick overview of the technology. I don't know if it's coming through. This tray is not on fire. There is kind of a mist coming out of that one. This is an early stage aeroponics trial that's going on. So it does look a little like the tray is on fire. I can assure you it is not. But that was a really big part of what we want to do, is actually then look at third-party technologies where IGS is not developing the solution. We can actually work with partners who have developed that. And you'll see some of the other examples here. There's a sensor mounted there that's actually looking at the fluorescence from the chlorophyll in the plants and able to extract information that uses the plant as a real-time sensor of that environment. And we can also use the lift just to use image recognition and take photos and actually then analyze those for specific characteristics of the plant. And that can then start really be driven by machine learning and AI, is where that stuff will evolve in the future as well. So we're using that in some cases already for things like crop height tracking and stuff like that, but that will continue to evolve. And it's all software driven that allows us to be able to then update our customers as that technology becomes available, while their actual hardware will stay basically the same. for the operation. We see these towers being operational for 15 to 20 years quite easily with the type of technology we have in here. So I guess that's a good time for us to open up to questions on that point.
Thank you, Doug. That was really, really interesting to see all this, and I'll be taking through the different details around energy and lighting and water and all the different crops. That's the bit I always find most interesting, you know, to see what people actually grow and what can you grow. So that's been really insightful there, especially around trees and the growing cycles. I can't see any questions yet, so please don't be shy, put your hand up or put in the chat. I have a quick question. It's around skills. So you know, if you're a traditional grower and you obviously know how to grow certain things, and you've been quite you know, experienced in that over the years, like how different is it to grow within a vertical farm environment? Is there a lot you would have to kind of learn and upskill yourself on, or is there quite a lot that's transferable? How does it work?
No, so that's a really good question, actually. So one of the big ones we find more with the traditional growers is actually keeping them out of there. So people are so used to actually having that direct interaction with the plants and then transferring that knowledge that they have and the experience. So when we give this to real hardcore growers, they want to go and look at everything because they want to constantly manipulate and change things. And that's probably, from a skill set, it's so important still that we maintain that skill set on site so that they can continue to evolve the crop. But actually, it becomes a hindrance in some regards from a production facility perspective, because they're constantly becoming the variable themselves. So what we try and do is actually work with those types of growers to translate the knowledge that they have, because they may know how to do something better that can accelerate that process. So we have what we call our hypercare team. Is their job is to take the best of their knowledge from the grower and help them translate that into their operation, so it becomes specific to what they need to do, and that gives them their own IP beyond what IGS is able to offer and helps them have a facility that works for them, basically. Hope you're on mute there, Andrea.
Sorry, and on mute. Thanks, that's really great. I've got a couple of questions now in the chat. So a question from Ken. He's saying a lot of the discussion has been on research. What about real commerciality? Is there any commercial vertical farms in place right now?
Yes. So research is such a big piece of this, and it's really a big important part of us for this. So this whole facility is about research, and the research will never stop. That's a core part of what our offering is, that plant science piece is. But from a commercial production system point of view, yes, we have operations both in the US and Europe that are using this facility commercially. We also in the Middle East as well have facilities that have crops being provided to the local market there, and that's where we're seeing the biggest opportunity in the near term, is the expansion of that to do that. And the idea is that they should be fairly robust and able to just start producing as much as they can. There will always be some local variable conditions and training that we have to make sure we provide people. But that, again, is that translation of the research that we've done into their operations that allow us to be able to get people to that point as quickly as possible.
Good. And I think you've already answered the next question as well, because Keith is asking who at present kind of are your main customers? Is it mostly trial work, or is it commercial growing for direct markets? So
probably our biggest customer right now is actually looking at this as a nursery facility. So the current operations as a nursery effectively. The bigger operations will still be using that for quite a broad and diverse range of crops, but that's the next opportunity. We see the nursery piece really being quite useful in many markets that becomes criticality.
Yeah, no, that makes complete sense. There's a question from Karen around the harvest system. So how automated can you make the harvest system or harvesting in the facility?
Yeah, so essentially that's very similar to the seeding line. It can be something that is incredibly highly automated. And obviously when we're talking about a facility that's 200 towers, that becomes a real criticality that we don't have people running around with scissors and things. So it's a big challenge here because it's small scale. We've had to sort of bodge a few machines because these machines can be €250,000 very easily. in terms of a lot of the big Dutch machines. So it has to have the scale to justify that. We're in the process of, we have late stage prototypes of automation to actually move the GTLs using robotics from the towers to that area and have that interaction. So right now it's still a manual process to move the crop from the tower to the harvest line, but as soon as it's there, it's all existing automation that does that process. It's stuff that is like the seeding line straight off the shelf and able to be accommodated very quickly with a number of different suppliers that can provide solutions for that.
Okay, great, thank you. Karen, I hope that's answered your question. Then we've got a question from, they're coming in thick and fast, by the way, so we're just working through them. So got a question from Richard. What is the capability at present to make smaller farms of this nature? So I guess you talked about quite large scale operations so far. Is there any ability to make it small?
We actually see a lot of our customers and prospects are people that have already got sort of container-sized farms and are now looking to scale up, because that's where we see a limitation. For us, it's actually, we kind of don't want necessarily go the other way. So we do 1 6-meter tower is kind of our smallest product we do. And that's about 200 square meters of growth area, but it's capitally quite intensive. So it can be quite prohibitive from that option. So we've really designed this technology for the larger scale operations. We work with a lot of companies that can do smaller scale solutions, and that's a really good starting point. So a lot of this is about actually the ability to sell plants. So it's being able to demonstrate that and be able to get those off takers in. So that's where we're seeing there was a big wave in the recent years of people getting, young startups building rack systems. It's really easy at small scale compared to the big scale. That's where your power becomes an issue, your ventilation becomes an issue. And the automation becomes an issue. At a sort of container level size, everything is by sort of default much simpler in its interaction. So we haven't focused on that area of the market, but it's certainly an area that is necessary in many cases, we believe, but allows us to be the next level up of that solution when the time comes.
Yeah. And I think that's actually quite a good point. And Ken is picking that up in a comment there as well, that obviously you specialize in these growth towers and other people specialize on container conversions. I think there's a few firms around in the south of the UK that do that kind of thing. So yeah. You've not got any interaction with them as such. You just obviously are aware of what they're doing.
Yeah, so quite often they'll have bits of technology that they maybe have invented as well that they want to put into that. So again, there's sometimes interactions on that sort of hardware front that we look at or sensing that they maybe have. And again, if we have a customer that's too small for us, we're quite happy to work with other parties, say, well, these make sense, but remember us in the future. And likewise, they'll get people that come in with, I want 100 containers to do this, and they say, we're not really in position to do that. So it's actually the UK market is actually quite a decent environment for this technology. We see organizations like the UK Urban Agritech Group are very welcoming to everyone from all different sort of scales. And that actually creates a really good ecosystem to operate in and share knowledge that helps everybody. And where there is bits of technology that people actually, it'd be good if somebody did that. It's much more opportunity to then work with the academics and groups like that can go off and research those challenges. So it creates that really good ecosystem that we found to be very helpful, and hopefully as others have found us helpful being part of that ecosystem.
Yeah, no, that makes much sense actually. So I've got a question here from Derek. I hope I'm reading this out right, but he's asking, can NPK and other nutrient additions be optimized by measuring ambient NPK in the growing medium for any specific group of growing plants?
So it is definitely a target of ours right now. The challenge we've had in the past is obviously we break everything down into the sort of tower scale. So the type of sensing that's normally used to sort of manage and monitor it in sort of real time, that process is prohibitively expensive to then sort of decentralize like that. For us, it is all about NPK and sort of optimization for specific crops, and we'll see some. What we can do with that, though, is once we understand the relationship from the research piece, is that because the towers are then decentralized, we're able to then have much firmer control over a smaller growth area that allows us then to focus on that specific crop's requirements, essentially. So it's definitely an area that needs more research and more interaction as to how you automate some of those processes and manage them over time. It's still got a few niggly sort of manual parts, and having to send samples away But effectively, it's something that we would look to be working with others on, that sort of type of technology, and then being able to interact and monitor that within the environment.
Mm-hmm. Okay, thank you. The next question is about the energy consumption. So I've got a question here asking, can the facility rely solely on solar powered system without a backup from the mains?
So in theory, yes, it would obviously still need some battery, but what this is kind of one of, again, the next areas of the research for that direct interaction with renewables is what liberties can I take with the growing to be able to maximize the use with that specific asset, essentially. So if we're looking at solar, it doesn't make sense to use an 18-hour growth cycle because you're going to need quite a lot of battery storage to be able to do that. But if I can reduce it to 12 hours, I may lose some of the yield, but maybe there are other interactions I can create within that. So this is, again, part of our research roadmap, is to look at how we then optimize the specific growth recipe to suit the energy asset that we're connected to. So we know in theory it's all possible. It's one that we've been able to make sure that interaction can happen. It's then just for what specific products does it make sense to do that? What other ones would it not make sense?
Yeah, no, that makes sense. Question from Ken, how do you arrange a visit to the facility if that's allowed? So I guess they can just get in touch with you directly. And
yeah, we have a section on our website which allows you to get in touch. That's one of the ways. Otherwise, I think there will be details available after this for others. But I would say that the website does get through to us. So please feel free to use that portal. It does get picked up and it will get sent to the right people.
Yeah, that's great. I'm going to take a few more questions. I might run out of time here, but we'll see how far we get. There's one question from Andrew here. Are you finding capital investment required is a barrier? I guess, Andrew, you mean from the customer's point of view, for customers to be able to actually afford the capital investment?
Absolutely, Andrew. Yeah.
Okay, perfect. Thanks.
Yeah, so yes, simply it's one of those, and this kind of actually goes into the smaller facilities often fall into that sort of no man's land of investment as well, where it's not quite big enough to get people interested, but not small enough. And that's where, again, that sort of container to the larger scale up piece is actually where we see people have £100,000 investment is relatively easy to get. £20 million investment is relatively easy to get. If you fall in between that, that's where things start getting a bit trickier. So it's really about trying to balance that between the scale of the opportunity and being able to speak to the right investors. But ultimately, it all comes down to if you have a good enough business plan that is demonstrating that. And again, that's something we really help our customers do, is build their business model according to the specific crops and the data that we have from our trials here. We work with them. And that's a big part of my role is that interaction of what is it you're trying to do, for what purpose, what's the offtake price. And we can build a very comprehensive model that gives you the basis of that business plan to go and get that investment. And if it's the right model, they will get investment. We've seen that. If it isn't, then funnily enough, you're stuck in that cycle, and you can blame the investment community for that. But actually, a good business plan will get that investment. What we're seeing is there is much less risk, so a lot more has to be demonstrated, and that's not always easy, especially if you need to do that scale up piece and you haven't done the small piece. You're going to come into this as a new entrant. That's one of the barriers, is that people want to see evidence that you can do this at scale. That's almost an impossible task, because if you don't get the money, you can't build it. If you do get the money, you have to then make sure it works. So this is where, again, this facility is used in quite a lot of cases to give proof of concept data, so people have the evidence to say this is a product. They can take it to off-takers and actually have that interaction directly to show this is a real tangible thing. And this type of technology is able to achieve that. So that's one of the measures we've taken to try and help build that profile of people that we're trying to get that investment, is give them the access to the actual physical plants off the back of the technology.
Yeah, no, that's great. I'll take one more question, maybe two. So there is a question around, what are the primary temperature and irrigation control strategies that are currently being employed? Is it around balancing energy efficiency and maintaining optimal growth across all sections?
It definitely is, and that's ultimately what we look at. There's always going to be some kind of compromise. Perfection is not needed. in most cases, unless you're doing really real precision stuff. Actually, there will be some compromise in terms of trying to manage efficiency. Ultimately, for most people, it's all about yields to, so kilograms per kilowatt hour are absolutely critical. That's what we try and focus on. That will come at a trade-off of the quality. It has to be up there as well. So yield has to be marketable yield. It can't just be it weighs that and therefore we got it really efficiently, but it's a terrible product. That doesn't count for anything. So it is a real balance between those things. It's more related to the energy, the lighting loads, and that interaction with the environment and what you're getting out of that, as opposed to the water inputs, because we recover so much of that. It's less of a cost for us to factor in, and from an efficiency perspective, we're recycling that. But the energy piece has to be optimized. A fundamental concept of this.
Yeah, thank you so much. I think we've run out of time now. Unfortunately, there's a couple more questions, but maybe we'll manage to answer them separately. But yeah, Doug, that was really interesting, and we really appreciate your time taking us through the facilities and answering all the many questions we've received. I think this webinar again has proved to be really popular, and the questions just keep coming. So I think it's just a really interesting subject area that a lot of people are interested in. So we're again obviously looking forward to having you at the main conference, at the A3 conference in September. But I want to thank the audience for being really involved and engaged and asking so many questions. We'll send out an email afterwards with all the relevant links and contact details. And please, yeah, feel free to get in touch with Doug and the team through their website if there's any further information you want to ask for. But thank you very much for taking part in the webinar today. Thanks, Doug. Thank you, everybody.